You may not realize that proportions appear sometimes as ratios. Red to yellow is 3:2. Or equations on a conversion problem. 10 logs equals 3 dolts. Or maybe it's fractions in a probability problem. The probability of an event is 2/5. Or an age word problem. John's age is 1/3 of Zach's. Today, I want to develop a framework to solve the most basic proportion problem. Start with the simplest case. How do we set it up? How do we proceed toward the solution? And then once we've mastered that, we'll extend it to more complex cases. Because ultimately, all these presentations are the same concept at play. So by learning one concept and method, we can potentially solve a whole host of different problems on the exam. Let's start with the fundamental case, the single proportion problem. Essentially, this problem starts with a fixed ratio or proportion of things. Blue to red is in a ratio of 3:2, for example. In addition, you're usually given the actual amount of one of the items. For example, there are 27 blue items here. Or perhaps you're given a total. The objective of these problems is to use the ratio, the fixed ratio, and the amounts given to find the missing amounts of the other elements, or again, possibly the total. So how do we do that? We need to form a proportion equation from the given information in the problem. For example, a proportion equation structure is A divided by B equals C divided by D. This is our typical proportion equation. When given ratios, the way we can do that is by essentially taking the second ratio and swinging it underneath to make it the left side of our proportion equation. So B to R becomes B over R, the number of B over the number of R, and that equals our fixed proportion. Again, swing the second part of the proportion under the first as the fraction, 3 divided by 2. So the number of B divided by the number of R equals 3 divided by 2. At this point, I know how many B's I have. The amount of B's given in the problem was 27. I'm going to substitute that amount in for the number of B's over here. Now I have a proportion equation with one variable that I can solve for, R, and it answers the question on the simple case, how many R would there be given the fixed proportion if there are 27 B's? And the answer is R equals 27 divided by 3 is 9 times 2. R is 18. If we were told the total amount of blue and red is 45, for example, we would proceed essentially the same way to start. We'd set up our proportion equation. Blue divided by red equals 3 divided by 2. In this case, I'm going to solve for one of the variables in terms of the other. So for example, B equals, after R divided by R is just 1, canceling, B equals 3 halves R. Okay, well, it's not a numerical answer like before in the last case, but now I can use this with my second equation for the total amounts. B plus R equals 45. I know what B is in terms of R. I'm going to take that and substitute the other way for B in my total equation. B is really 3 halves R. Plus R is just, well, R equals 45. Now I have one equation, one variable I can solve. And that becomes 1R, or R, equals 2/5 times 45. Well, 45 divided by 5 I know is 9, so that's 9 times 2. R equals 18. And that answers the question. How many R are there if the ratio B to R is 3:2 and the total amount is 45? Let's look at another presentation format. In this case, my fixed proportion is given to me as an equation. like 3b equals 2r. And they'll obviously stand for something. Maybe that's 3 British pounds equal 2 US dollars. And then I'm given an amount again. I have 115 B's, maybe British pounds, if that's what the problem indicates. How many US dollars or how many R's can I convert that into? So again, we want to set up a proportion equation. How do we do that in this case? In this case, we would take the elements of what they are, the B and the R, and we'd again pull the second part under the first. So that would be B divided by R equals, and the numerical values or the coefficients of those variables will pull the one on the right down under the 3. So that would be 3 divided by 2. This would be an equivalent proportion equation for the 3b equals 2r equation. B, the number of B divided by the number of R equals 3 divided by 2. If you wanted to put that in an intermediate ratio format, we could. We would just simply say that's B to R, the left to the right, is 3 to 2. And then we do the same thing as we did before. We pull the R under the B, the 2 under the 3, and we get this proportion equation. Same concept, just a different delivery presentation. Let's look at another case where the information is presented as a fraction. Now that could be part to a whole, say in a probability problem, or it could be a part to a part, say John's age to Zach's age, part 1 to part 2, is 1 to 3. So if we know J, John's age, is 15, we could substitute that into our proportion equation. We're already a step ahead of the game of the previous presentations because we essentially have our proportion equation set up as fractions already. So I would substitute 15 for J. 15 over Z equals 1 over 3. The result is Z equals 3 times 15, or 45. So Zach's age is 45 in that case. It's almost a little bit easier. The part to whole case, let's suppose we do have a probability problem. Perhaps the probability of an event is 1/3. Okay? So in this case, 3 represents the total, not the partial amount. In this case, we're given an amount. Say there are 90 samples taken. I'd set up my equation. Part to whole equals 1 to 3. That represents, out of a total of 90, how many would meet whatever condition, be the part. Maybe it's the number of blue marbles picked out of a bag, etc. And we already have our proportion equation set up for us, and N would equal 90 divided by 3 in this case, which equals 30. At this point, we've touched upon many of the different presentation formats for our single proportion case. Basically the fundamental or basic scenario we'll run into. And we've seen the different presentations as ratios or equations or fractions, which we then convert into a proportion equation.